Yes, we are live. It says to me at least. All right, we'll see. All right. Thank you, and welcome everybody to the sprint review. The platform sprint review. Welcome the audience and the 5 team we have here. We are planning this session for 1 hour, and we are going to have a Q&A session at the very end. So please feel free to ask your questions, and please also include the context of that question. So when we read those out loud at the very end, we also know the context you are asking in. My name is Balázs Bézi. I'm a Scrum Master for the platform teams, and please enjoy this review. And I'm passing on to Dima.
Yeah, hello everyone. I'm Dmitry from TenderDash team. Quick update for the past sprint from our team. So basically, we finished everything what we planned on previous time. And the biggest achievement is, and biggest part which we already finished, is finalization of backport ABCI++ without some block execution for now. And the outcome of this task is we created pre-release of V08 with ABCI++ that can be used drive team for development to support ABCI++. Because the backward compatibility was broken, and in order to interact ABCI application with the TenderDash, we have to re-implement our approach. So second big topic is work on improvement for word extensions. We added, I would say, we refactored completely word extensions with the same behavior which we have in Tendermint. And currently, we introduced a new type of word extensions, that threshold recover type that is used in order to recover signature for every extension in the list. And yeah, of course, we changed the way from the one word extension to the multiple ones. And currently, we're going to use this feature for withdrawal transactions. We plan to finish this task next sprint. Basically, this task is in the review at this moment, and yeah, I hope we will done next sprint. As a bonus or unplanned task, we started working on validator keys verification. The effort we're going to put into this task is to fix man-in-the-middle security issue, which we have at this moment. This issue was described in ADR, probably, as I remember correctly. So we found the easiest way how to eliminate it without touching the code base a lot, but with the same outcome. Yeah, that's pretty much it from our team. Thank you for attention.
All right, thank you very much. Let's go forward with the GroveDB team.
I guess I can just talk about the goal, and then we
All
can.
Right, thank you.
Yes, Samuel Westridge here, CTO of Dash Core Group. The main goal for GroveDB was understanding deletion costs. Deletions are very complicated, and they're kind of what's holding up our fee model right now. We built everything, over a few iterations, and deletions were causing an issue. So we decided that we needed to handle this in GroveDB to be able to better assess costs back to Drive. The task actually extended in scope just because it was easier to do it that way, and instead created a fee framework in GroveDB for all GroveDB costs to be passed back to RS Drive. This basically means that for GroveDB, when you make an operation, you can ask to get back every time it seeks somewhere on the disk all the size of all memory that it used for that operation, and a lot of other interesting things. And this will make us be able to finish fees. The other teams outside of GroveDB, very quickly, we've kind of been pausing fees and been working on the next features. Not pausing fees. We worked on fees, but we not as much as in previous sprints, mostly because, well, yeah, we needed this fee framework from GroveDB. On top of that, the proofs had already been made, but there's been a lot of work on documentation on how we make the proofs. And so we can release a document explaining the math and behind proofs. We also integrated the proof system into Drive, so we'll be able to return proofs very, very shortly to clients. Okay, next slide, please. Yeah, so Wisdom, you want to take it?
Hey guys, can you hear me?
Yep.
Yes.
Okay, cool. So we continued work on proof documentation, a lot harder than coding. Well, we made some progress with that. We're close to a first draft, so once that is done and it has been reviewed by the team, we can now release that for everyone to have a look. We integrated proofs to RS Drive. So now RS Drive can make use of the GroveDB proof functionality. And then we updated all the RS Drive tests to also requests for proofs rather than just queries, and then everything passed. So we are highly confident in the proving logic, basically. So I have a very short demo to show RS Drive working with proofs in the RS Drive Explorer. So I'll share my screen now. Can we see my screen?
Yes.
Okay, cool. So this is RS Drive Explorer. I'm sure we're familiar with this. I'm going to load the person contract by just typing P. So now I'm going to insert, let's say 100 random documents based on that contract. Okay, cool. So before we had select, and then you put in your SQL query. Now we have this new prove, which also takes in the SQL query. So I can prove everything from person, for example. So what this would do is it would request. So it's not a direct query this time. It's actually requesting for the proof from the GroveDB instance. Then it would verify it locally and then compare the root hash with the state or the non-state root hash. And then if it is valid, it would print out the result. If it's not valid, it would try an error. We also added, or I also added some statistics just to see how much more data is being used for proofs. So let me just run this. So this is the results from requesting all person documents. So it says root hash is valid. Then the proof size is 24,000 bytes, but the actual data size is 23,000 bytes. So we had like an extra 1,000 bytes for just like proof related information. So that was like a 5.6% percentage increase in terms of the data and the proof size. So this is really, really good, but then that's because of the we're requesting everything in database. So once you start to request prove everything from person where age, let's say, equal to x. Let's order by age. And you see that it is now like drastically different and this is because of the data is just so small, and proofs require 800 and something bytes, even if there was no result set. So when you compare that, obviously the percentage increase is going to be a lot, but then the actual proof size is still just 1000 bytes basically. So that's the demo. Moving on to Sam to explain the cost framework.
Yeah, thanks, Wisdom. That was great. Yeah, it's really very nice to see proofs. I love proofs. in cryptocurrency, proofs are everything. Blockchain, basically. Okay, so yeah, as I was talking about earlier, we have created a computational cost framework. Evgeny did amazing work here, where basically all actions in GroveDB bring up the costs, and these are how much memory is loaded, how many seeks on the database occurred, how much data was actually stored, how much data was deleted. And all of this is given back to RS Drive so we can figure out the fees in a much more simplistic way than having to try to like figure it out in advance. So that's done. So now we're going to be able to use this framework that was kind of, originally we did not realize that this was a missing piece of the puzzle, but it later became apparent that we needed this, and trying to do it in any other way was just making us waste time. So we did the work, and now we're going to be basically in the next sprint integrate this work into RS Drive to give final fee to basically finish fees. Cost accumulation. Sorry. Yes, and then. But Evgeny did really want to mention that there are still improvements. He wants to verify that even though the system should be working right now, he just needs to make sure that there hasn't been anything missing and the efficiency of the system is perfect or good enough. Okay, well, that's it for GroveDB tasks.
All right, thank you.
Yeah.
Hey everyone. Yep, I'm around. So for SDK, the main sprint goal was to integrate block header string from DAPI into the wallet, and this task is kind of a prerequisite for a proper chain synchronization for the wallet and the whole SPV. And we also continued on the SDK documentation updates. So first of all, we finalized the fix for incomplete SDK bundle for the web. It is released in -3.22.12. We integrated block header stream into the wallet, and the rest of the chain synchronization refactoring is currently ongoing. So there is no, I didn't manage to do a demo this time, unfortunately, because of some performance. But hopefully next time I'll show you something nice. SDK documentation is in progress, and yeah, this is it from my side, and I'm handing over to Mikhail.
Hey everyone, my name is Mikhail. I'm from SDK team, and last sprint we was working on the several things. One of the major things is the upgrade to the new Docker Compose v2 engine. The reason is that Docker itself evolving, and it has been rewritten its Docker Compose engine, and it's now bundled into the Docker engine. and the Docker Compose utility binary will soon become legacy. So this will allow us to remove the dependency on Docker Compose, so less requirement on the installation of the project, and also will stabilize the Docker features because the Docker Compose will be now the part of the Docker, and it will also evolve. And also the next thing is the flag for faucet file storage directory in platform test suite. And the thing is that when you were running platform test suite, there was some temporary files that was put in the current Git working directory, and it was messing up the current dir. So we just moved that to some external folder, and also edit the flag to point where to store these temporary files. Also, we checked the documentation for this platform to suit binary execution, and yeah. Also, we were investigating Dashmate setup issues. We investigated few bugs and few inconsistencies, and added a troubleshoot documentations about these cases. Also, we were spotting the issue with the high dash core CPU usage, which is still in the progress. So these bugs are now currently listed. This bug that were found out during the investigation, and yeah, we will solve in the next sprints. So that's it from my side.
Thank you, Mikhail.
Thanks. My name is Ivan Shumkov from the platform team, and I would like to talk a little bit about the protocol work during these 2 sprints. Our goal was to finalize fees and fee distribution pools. I think the wording is not correct here. We continue to work on the fees, and also we worked on the distribution pools. Yeah, let's be more correct. Next slide, please. So we already discussed that we need special logic to predict fees, since we are not running the entire state transition execution process to calculate the initial fees for state transitions. So we need this, like we call it dry run, when we run functions and functionality in DPP, in JS Drive, and Errors Drive, but without actual execution of the database operations. We're just counting operations and counting costs for them. So we can predict how much fees we need to process the state transition. So we did some work on JS Drive side, and we accomplished implementation in TPP and JS Drive. We also implemented many tests on top of them. So we created different types of state transitions with different data and compared prediction fees and actual fees after the execution and prediction fees must be higher because we usually use the worst case scenario, like how much it could be if we are with the biggest possible data, because when we predict the fees, we don't have access to state, right? And this work is done. And right now, Drive calculates fees properly, and predict and calculates actual fees properly. We did some benchmarking on this, but still some work needed on the RS Drive side, and Sam already mentioned that. And yeah, getting closer, I would say. Thank you. Javid,
thank you.
like to talk about the pools?
Sure. Javid from Platforms here. I'll try to explain our work on fee distribution pools. So first of all, what is fee distribution pools? So we've doing this work to introduce a delayed reward distribution. So and eventually to introduce to allow our system to pay out fees to masternodes. And this work is split into several steps. First one is to collect the processing fees, which are calculated based upon CPU usage. And the second one is to collect storage fees, which are based on how much storage is being used. And we distribute them into several ways. The processing fees are stored into a pool directly, and storage fees are split across 50 years of worth of pools. So the pool is a special fee, let's call it fee storage, a place where we store fees, and they are rotated roughly every 18.5 days. So every 18.5 days, we're getting a rotation of those pools and making a payout based on how much fees are gathered by that time. So the initial work for fee distribution pools are done, and I should mention that it's done in RS Drive, and we're lacking testing and integration with JavaScript side with JS Drive. So this is state of things about fee distribution pools. Regarding the second item, so we decided to limit the amount of documents you may create for the reward shares to protect system from overloading it with enormous amount of shares, and then halve the system with amount of payouts needs to be done. So we limit those to 16 now. And that's about it, I guess. Should we move on?
Let's do it. But very quickly, I'd just like to explain, people are looking and probably going, Masternode shares, what? This is actually more of a future proof. When we designed the Masternode reward contract, we allowed shares to the owner, to the operator, and 15 others for future use. And that's just how we built it. Before we allowed up to 32, we realized that it was very costly to do up to 32. So, dividing by half there really would help. So we limited it to 16 instead of 32. And that's the reason why you see it here.
Well, thanks for covering me up.
Yeah, no problem. Yeah, so here, this is basically some other work that was done. we had previously talked about adding batches into GroveDB. GroveDB basically, using batches will allow much quicker insertion, as well as it should prevent something that I can call dangling inserts, where while we already have transactions in RS Drive, if we didn't do this feature, there is a possibility of a dangling insert on the transaction that would result in having to wipe the transaction and start over again in the case of an error. With batches, we can, go back. No. With batches, we kind of solve this problem. That code has been written. We also allow RS Drive to be configurable to either have batching or non-batching. And yeah, before doing this though, I also built a benchmarking tool for RS Drive Explorer. It's on a different branch than what Wisdom just showed, so things might look a little bit different. But I'm going to present that benchmarking right now. Give me 1 second. Just have to find the, yes. Oh, here we go. Can people see my screen?
Yes.
Yep. Okay, so basically here we can do a load last, which just basically loads the last contract that I have used. I think it's the -pay one. Let me check. View, contact info, contact request profile. Yes, it's the -pay contract. So I can basically, instead of just doing a populate or a populate full, I can do a bench pop. So basically, I'm just going to benchmark how fast this goes by going bench pop, and I want to insert profiles. I want to insert 10,000, and I want information about my inserts every 1,000. So I can just run this. Let's see what happens. Yeah, so it basically is inserting 1,000 at a time and giving you how much it's costing for 1,000 at a time. So 1,000 here is costing $5. Each time we insert in a profile, that actually is 6 inserts into the tree, if I'm not mistaken. So into the GroveDB tree because of secondary indexes in this contract. And we can actually see the queries. Now, this is kind of just the raw data. There's actually another kind of hidden option where you can type in CSV and it will export to CSV. Then you can use the data. I did that and I created a little graph to share with you guys. Let me share that now. Can people see this as well?
Yes.
Yeah, so it's actually pretty good. And this is without batching. Let me explain that. So once we have batching, we should actually get this much faster. So basically it's time to insert 10,000 profiles on my machine based off of how many profiles currently exist. And as you can see, the time does increase, but it's definitely not linear. It's somewhat logarithmic, and this is actually really good news. GroveDB and RS Drive are extremely fast. It would seem like, yes, it leads us to about 5,000 profiles, I think. Wait, I'm not sure about that. What is 10,000 divided by 30? 333 profiles per second. but this is without batching. So when we do have batching, I expect like a significant increase, and this is also just on my local machine. We can also see that the queries, as the data size grows quite heavily, it doesn't seem to really increase that much as well. So we have this logarithmic increase in cost as the database gets bigger. And up till here we have it's 1 million. Yeah, I did it up to 1 million profiles, which represents about 6 million total GroveDB nodes. So it's quite a lot of data on disk. And it's very encouraging results. And this is before RocksDB optimization, before tons of other things. Basically, we have a very fast system before we get to the optimization phase, which is nice. Okay. Let me stop sharing this and you can share again, Balázs.
One second.
Yeah, no problem.
Yes.
Yeah, one other thing that I worked on was something called conditional recursive subqueries. This was to fix a bug that was reported by the incubator. I'll quickly explain technically why this was complicated. I mean, it sounds, I'm sure people who don't understand what that is, it sounds very complicated, and it was. Basically, when we have indexes in our data contracts, you can query indexes without querying the full path. For example, if you have an index on first name, last name, and you do a query, give me first name equals Sam, no, first name superior to Sam, that query will work even though you have a double index in your data contract. However, to support this, when using start at, we have to do something that is called a conditional recursive subquery, where you go down the actual path of the start at, and you only want to get elements after it. So, you know, this is one of those things that takes a lot of time that really wasn't planned, but it's done. And, you know, it not only is done, but it was very complicated. And then we built, we checked to see if the proofs worked on it, and it did. And that just goes to show that, you know, the work by Wisdom is very, very good. Okay, cool. So that's it. Let's move on to the Rust port update.
Anton.
Yeah, sure. Hey guys, my name is Anton, and I'm working on Rust port with my colleague Pavel. And as you can remember, last time we decided to present this kind of a small progress bar, so you can actually visualize how the progress is going, because porting something is a finite process with a known end goal, so we actually can quantify the tasks we need to complete to accomplish before we can call it complete. And so because of that, we've decided to present this as this sort of a progress bar to be able to more easily visualize what we were working on. But you probably already know that if you were on the previous sprint review. So during this sprint, we worked on the remaining stuff for validation of data contracts and documents, as well as some validation for identities still. And yeah, as you can see, we had about 8 progress this week. I mean, this sprint, compared to previous sprint, about 11%. So we figured out that on average, we progress about 10% per sprint. So here we go. We kind of on track in that sense. Now, the one thing I wanted to address is that I've seen some comments that some people think that this Rust DPP port effort is for the whole platform. Now, let me reiterate something, right? Well, first of all, there's only 2 people working on this right now. So it's not like the platform development is going exactly the same way as it went. It's just 2 people working on porting the platform protocol. And that's exactly the point, because we want to develop this in parallel and then later on replace protocol with the Rust implementation. And also that particular part is specifically protocol port and not the whole platform. So the whole platform actually consists of 2 more things. Protocol is the biggest part of the whole thing, of the platform, but we also have API that actually connects clients to the platform. And then we also have something called Drive, which processes state transitions and stores them on disk and actually uses protocol to validate and verify data. So although the DPP is the largest part, it's not everything that we have, as we have those 2 components. And we plan to gradually integrate new Rust platform protocol implementation into those things, and then maybe touch them a little bit later. So this progress doesn't represent like the whole platform, but just only the protocol part, which is, again, is the biggest part, but it's not everything that we have. It's not all the code base we have in platform. It's just the protocol part. So
biggest part by far.
Yeah,
right?
Kinda. So although this is somewhat representative of the whole progress, it's not it, right? So we still have some work to do on Drive and DAPI if you want to. And DAPI is just a simple proxy between the node and the client. So it's not a big deal when it's not a critical in a sense that, well, it's just a proxy. So it doesn't have to be as precise and as a protocol. And Drive is also an important thing, but it still works right now with JS code base, and we're just going to integrate this protocol port into it and then see how that goes. So this is an update and some clarifications on the Rust DPP porting effort. And I guess I'll give a word back to Balázs.
Yeah, thank you. Thank you very much. So let's move on with what's next for each teams.
Yep. So I'll take this. Basically, what's next on the protocol side is to finalize the fee distribution pools. We talked about that this week. We're nearing the end of that. We just haven't finished. I don't think we ever planned on finishing this sprint, so we're, I believe, in advance there. Respond with proofs with signature. I don't think we even, we're also kind of, I believe, in advance there. So that would be next. The basic, as I said, GroveDB proofs done, RS drive proofs done. Now we just have to chain, I mean, basically the JS drive part that's written in JavaScript gets the proof, but doesn't hand them back to light clients yet. So we just need to do that last little thing to hand them back. And without signature. So very quickly, why without signature? Well, the work that you guys might have been hearing about same block execution, we're doing that to be able to get this signature that is the last piece of the puzzle for the proof system. So the proofs are a Merkleized AVL tree that is able to prove any data in the state. And then the signature is made by the quorums, also known as validator set, that sign the root. And the two things together prove any information. While we have the signature in old, we've made this signature already, without same block execution, the signature is actually for 2 blocks ago, based off of how Tendermint used to work. And because it's too old, we have this chicken and egg problem where we're constantly trying, I mean, not constantly trying, I mean, we're basically 1 block too far away. That is why same block execution is so important. Tendermint realized this, a lot of, and we were going to implement it ourselves, but we realized that they're doing it. So we've kind of waited for them to have it. So we worked on other things, and then we're just going to kind of hopefully take it, not for free, but with less effort. And then continue on fee system. We've been working on fee system for quite some time now. Hopefully, now that we have the GroveDB part of the fee system, we'll be able to finalize the RS drive, and then basically it should all be completed. Yeah, on SDK, we are reworking the chain synchronization process for SPV clients. This is because of slowdowns during chain synchronization. We have noticed that the SDK repository documentation needs updating, so we're working on that, and we're stabilizing Dashmate because of some known issues there. So we're on GroveDB side, we're actually kind of nearing the end of what's needed for mainnet. The last 2 items are checkpoints and chunking, and then there might be some optimization to make us be able to support more transactions per second. But yeah, the 2 biggest things are checkpoints and chunking. Checkpoints basically allows for, they both allow for state sync and light client and inter-blockchain communication. So yeah, that's it. It's not as big as effort, in my opinion, as batches or proofs. Far from it. So yeah, and what is chunking? Very quickly, basically, if you have your whole state of your database with all the trees, imagine just like nodes all over the place, you can, to try to replicate it from one machine to another that's syncing, that's like coming online, you can just take chunks of the database and push it out. So you have to create a checkpoint at a certain time, chunk, give out the chunks to the person that's new syncing, and it will vastly speed up the new node syncing process. TenderDash, we will pre-release with the ABCI++. This is on the line to same block execution. Basically, we have to do ABCI++. This gives us vote extensions and a lot of new features that Tendermint was building. And then we can, after that, do same block execution. And for the finalized withdrawal transactions, so what we've done here is we've talked, Dima talked about it, but the withdrawal transactions basically use the threshold signature that we've put in TenderDash. So with the vote extensions, you basically, validators will vote on something, then there's a final round of threshold recovery. And then with that threshold recovery, the network says something to be true. And then that signature is then used on the withdrawal transaction that Core can then use to give people Dash from platform credits. So validator key verification. This is because of a slight issue in how TenderDash works. There could be a slight attack. So we just have to fix that. And that's basically it.
All right, thank you very much. So let's move on to the questions. All right, we had 3 questions. Basically, Ryan asked those. The first 2 is testnet stable, and is the manual testnet setup up to date?
I guess I can answer that. Testnet is not stable. The reason why testnet is not stable is for 2 reasons. Currently, we are doing a test for V18 and on testnet, where we downgraded parts of our network to V17 to mimic the upgrade process that's going to happen on mainnet. And during this upgrade process, we've had to reindex a lot of nodes. We've had to you have some versions on V17, of course, some on V18, of course, and this is causing some issues for testnet. So I don't expect it to be stable until this, I don't expect platform to be stable until this test is done, probably towards the end of the week. And then the next question is the manual testnet setup. You mean I'm gonna guess you mean a DevNet with Dashmate. Or do you mean, Ryan, what do you mean? Or Ivan, did you understand his question? I can't hear you.
All right. In the meantime, while Ryan is answering, his next question is, are the platform tutorials up to date? Platform tutorials.
I would say no. Ivan, I would say no, correct?
Yeah. Wait, it was in progress, I guess, right?
It's in progress. I would say, so for Ryan, we identified this as the biggest issue currently, well, one of the biggest pain points that we currently have. So it was actually, we had freezed all hiring because of the current bear market that I'm sure everybody is aware of here. But we had kept that position open just because we realized like how important it is to have proper tutorials, and all the work that we're doing, people need to be able to actually use it, right? Now, recently we've actually shuffled things around, but we will be getting help from team members that are going to help on this for the next few months to get tutorials up to date. We also might have a volunteer coming in to do this, who's quite good. So hopefully platform tutorials will get better quite soon. We also kind of want to create websites for multiple for websites for GroveDB and websites for TenderDash. So other projects can integrate them. And people might be wondering, like, why are we happy that other projects integrate them? Well, when you have a strong community around an open source project, a lot of eyes are on it, and then we start getting stuff for free. That's one of the benefits for open source. A lot of people start, finding improvements, and it basically is we all work together to make better products. So hopefully we can expect those websites Not in a short time, but I expect them by the end of the year. And that should help.
Yeah.
Get work for free. Sounds like an evil plan.
I mean,
you had a question about the manual setup, right, Sam?
And also Ryan clarified the question so that he meant the documentation about how to set up a testnet dev environment and testnet Masternode with platform support.
Short Strophy worked on this.
Yeah, not only Adam as well, I believe.
Yeah,
I believe
Adam and Leon worked on this, but I'm not sure this current status, honestly.
Adam, are you?
Yeah, we can just ask him.
Hello, Adam.
Documentation, yeah. Hello. So the documentation for setup testnet is up to date, but there are some documentation around that which requires some improvement as well. I would say like that.
Can you tell us just a few examples? What do you mean around that? What specific examples that are not up to date?
Right. So the testnet setup section includes not only Masternode installation, like, but for example, the sections like before you begin and so on. And I think we missed some information, for example, in Masternode installation, which are included in the previous sections, and we didn't go through all of these sections from testnet setup yet. So yeah, to sum up, we need to wrap it up, everything, and update.
All right.
It's like that for now.
Do you have any projections about that? Or you would say?
I mean, we already started, but we don't know how much work it requires.
All right. So you're currently working on it. Thank you very much.
Thanks.
All right. I see no further questions. So is there anything else we would like to share? If nothing else, I thank you. Thanks for presenting and giving us an update. And thanks for everyone watching and giving us feedback, asking questions. Please keep it up and see you in 2 weeks. Bye-bye.
Bye, guys.
Bye.
Bye-bye.
See you, everybody.